Chapter 2, Lesson 2 of Pre-Calculus, going to look at power functions and modeling. We'll take a look at power functions and variations. We'll then look at monomial functions and their graphs, and then we'll look at how to model with these power functions once we understand what they are. So power functions are any function that can be written in the form f of x is equal to k times x to the a. And again, as we look at these functions each time that they are introduced, we want to take note of the different variables that are in the expression, and then we want to take note of what those expressions represent, what those variables represent, excuse me, and then how do we calculate those values, and how can we calculate those values. F of x is always y and x is always x. Everything else describes the relationship between x and y. So we have a k variable that we're going to need to know what that is and how we can calculate it, and we're going to have this a variable that we're going to need to know what it is and how to calculate it. Alright, so k and a, first of all, are non-zero constants, so we can use any value for a and k except a 0. The constant a is called the power of the function, thus this is the power function. K is the constant of variation or constant of proportion. So either of those expressions mean the same thing. Some things to know. First of all, it's a direct variation if it's a positive power. So if that a value, that is the power of the expression, is a positive number, then that's going to be called a direct variation. So when you're looking at a word problem or you're looking at a function being described as a direct variation, you want to think, oh, that a value is going to be a positive number. Inverse variation would be a negative power, and the reason is, you remember, if we want to make that negative power positive, we move it to the denominator. Now that x, or that x value is in the numerator, so now it's inverse to the y value. So a negative power would be described as an inverse variation. So again, as you're reading a word problem and seeking which power to apply to the problem, if it's an inverse, then that x value, that x variable, is going to be in the denominator, and then if you moved it to the numerator, it's going to end up being a negative power. Root functions are going to be fractional powers, so a square root, you remember, is x to the 1/2, or a cube root, x to the 1/3. So if that x value is a, if that a value is a fraction, then it's a root function. The constant of variation then is that k value, and every single power function has one. If it's not written, we don't see it, that's a 1. Any other number will be written there, and it can be more than one value multiplied together, which will show you some examples in the next slide here. So determine if the function is a power. So I have multiple functions here on this page, and we'll take a look at each one of these. Now it's very important to notice here that the letters C, G, K, and P are all constants. So if you see any of these letters in the expression, these are constants. They're not variables, so they will not be the relationship between that variable and the y. So we want to look at these functions and then state the power and the constant. Okay, remember the power is the variable, and then the constant is the number that's in front of the x. So if we take a look at this one right here, f of x is equal to 9x to the 5/3. Alright, this one little note here, kind of a trick to help you out. Whatever's in here, f of whatever variable's inside of here, that's the variable. That's the relationship between y and this variable that's in here. Everything else in the expression is either a constant or a power, or is a constant of or the power of the expression. So here x, I find x, so is this a power function? Yes, because x has a power to it. The power of the function is the a value, so 5/3, and the constant of the function is this number that's in front, 9. So yes, this is a power function. The power of this function is 5/3, and the constant is 9. Let's take a look over here. Is this a power function? F of x. Well, here x is in the position where the a is supposed to be in a power function. This is not a power function because x is the power, and in a power function the x is the base. The x is being raised to some power, or the variable is being raised to a power. The power is a constant. Here the power is not a constant, it's a variable, therefore it's not a power function. So let me say that one more time because I kind of brushed through that quick. Remember when we first defined power functions, one of the first things we said was that a is a constant. A and k were constants. Well, here a is not constant because it's a variable. So this is not a power function because the a value, or the power of the function, is not a constant. Let's take a look at, let's see, this one here, ke of v. So again, this v is the variable, so I find v. Does it have a constant power? Yes, so the power is a 5. Now what's the constant of the power function? Well, again, if you remember up here, k is a constant, so 0.5 times k, that's going to remain constant because k is never going to change, so the constant of this function is 0.5k. Alright, so that's how you determine if it is a power function or not. In the next videos, we'll take a look at how we can use these and graph these.